Hey guys, Dankman here. We're going to review the packet 2.1.2 in order to check our work on quiz 2.1. So please get this packet out, 2.1.2 from last week, how can I measure steepness? Go ahead and get the packet out. We started the packet by checking about these questions. And today, to help us understand the quiz, we're going to look at problem 211. Write an equation that represents the tile pattern in the table below. So get your packet out and look at this table. This table compares two quantities because all the functions in our class will compare two quantities. Figure number, 0, 1, 2, 3, 4, etc., to number of tiles, 2, 7, 12, 17, 22. So this table means that figure number 0 has two tiles. This table shows us that the function matches the input 0 figure number to the output 2 tiles. So if I were to imagine figure 0, maybe it looks like this. That's 1, 2 tiles in figure 0. And then, when we step forward one figure number from figure 0 to figure 1 has 7 tiles. That is a change of 5. So the growth rate here is adding by 5. And visually, maybe this looks like figure 1 has the original 2 tiles from figure 0 plus a brand new set of 5 more. That's 1, 2, 3, 4, 5 brand new tiles. So we started f of 0 had 2 tiles, so we input 2 tiles, we input 0 figure number and output 2 tiles, and then our growth rate is plus 5 tiles every time. And if we wanted to go all the way out to, say, figure 43 for whatever reason, then we can imagine the 2 tiles we started with plus a block of 5 for figure 1, and then we add another 5 for figure 2, and another 5 for figure 3, on and on until we get to figure 43. So that's figure 0 has 1 tile, figure 1 has 5 new tiles, figure 2 has 5 new tiles on top of that, etc., all the way to 43. So there are 43 blocks of 5 tiles. That's 5 times 43 total tiles, plus the 2 we started with. And so figure number 43, input 43, output 5 times 43 plus the 2 we started with. And that's equal to, what, 215 plus 2, I think? So 217. And so the strategy here, in general, is to write an equation for this function, this linear function that inputs something and outputs something. And it'll look like this. The input will be the figure number x, input figure number x, and then the output will come from this process where we multiply the figure number times 5, that's the growth rate, and we add 2, that's the starting value. And this is a general strategy for writing the function equation for this linear tile pattern, this tile pattern that grows at a constant growth rate of plus 5 every step. Now we understand how to write the function equation for a tile pattern from a table. Next, we're going to review problem A of 213. That's on the second page of the packet, and this graph, the instructions were to analyze the graph and to find the starting value and to determine the growth rate and then to write the function equation that inputs x number of tiles, x figure number, and outputs the number of tiles. Okay? And the instructions explain to us that the x represents the figure number. So the x-axis represents and measures whether we're on figure 0 or figure 1 or figure 2. And then we can trace up to our curve and find a point. And that point tells us, hey, your figure number x is 0, and your output, which I'll do in purple, number of tiles, y. And so this point 0, 3 represents that figure 0 has 3 tiles. In function notation, that would look like f of 0 equals 3. Again, that means figure 0, the x value, has 3 tiles. The y value. And if you carefully read the scale on the bottom, we see that this number 1 has 2 boxes. So the scale tells us that the number 1 is split evenly in half. So we have input 0, and then input figure number 1 is all the way over here. If we track figure number 1 up to the curve, we see that it goes to the point 1, 7, which means that figure number 1 has 7 tiles. And so what we've done is we've tracked the starting value, f of 0 equals 3, so that means figure 0 has 3 tiles. And then we went from figure 0, we went forward plus 1 in the x direction, which told us to increase our figure number from 0 to 1, and then we found what happened to the output traced to the new output, and we had to go from 3 to 7, which is a change of plus 4 tiles. So that's plus 4 tiles per figure. To write that equation, we're going to take the growth rate, 4, we're going to multiply it times the input, x, the figure number, input x, and we're going to add the starting value. And that is our function equation that inputs the figure number, x, and outputs the number of tiles. And the way you do that is you multiply 4 times the figure number and add 3. So for instance, we can predict that f of 2 will be equal to 4 times 2 plus 3, which is 8 plus 3 for 11. So this would indicate that figure 2 should have 11 tiles. And if we trace over to figure 2 and up, we can see we're going from 7, 8, 9, 10, 11. So right on that line, we should hit the point 2, 11. So our equation should give us a really good picture of what this line does, and any figure number we want, we can figure out the number of tiles by using this function equation, which we wrote by looking at the graph.